Hey guys, welcome back to Virtual Geometry here on the Croft Tube. It's Miss Dwyer jumping in for Mr. Crofton to help us find the area of triangles and other composite shapes. So our objective today is to find the area of different types of triangles and then develop multiple methods to find the area of composite shapes formed by rectangles and triangles. A major goal of today is to look at why is area so important? What do we use area to see? As we go through these problems, keep asking yourself, what kinds of shapes do I see in this diagram? Do parts of this diagram or parts of this problem remind me of other problems I've seen before? And is there another way to find the area of this shape? So to get us started, we need to look at finding the area of a triangle. Remember, the area of a triangle is 1/2 the base times the height. It's important to know that the base and the height always intersect at a right angle. Those lines are always perpendicular to each other. So whenever you're looking to find the base and the height, you need to look for where they're making a right angle. So let's take a look at problem 1 here. We have 14 yards here on the bottom, and we have 5 yards here on the side. And then we can see those two lines make a right angle. So we know that the base of this shape must be either 14 or 5, and we know that the height of this shape must be either 14 or 5. So once we've found our base and our height, all we have to do is plug it back into our formula. So our area equals 1/2 base times height. So our area is going to equal 7 times 5, which means the area of this shape is 35 yards squared. Always remember to add that yards squared at the end, because when you find area, it's numbers times numbers and units times units, so it's units squared. Perfect. Now, take a look at this shape. We have dotted lines outside of our triangle. But if we take a look at those dotted lines, notice they are making a right angle, which means one of those lines must be our height and the other one must be our base. When you have the dotted lines outside the triangle, it's showing you that the height of the triangle, the tallest part of the triangle, can't always be drawn inside the triangle. So our height here is definitely 10. I think where most people get confused is what's the base of the triangle? Even though we have dotted lines all the way over here touching that height, that blue line is not, I repeat, not part of our base. Our base is really just this 14 meters. So we're going to fill that in right here. So the tallest part of this triangle goes all the way up to 10. And the longest flat part of this triangle is 14. Any dotted lines that are part of the base do not get added in when you go to calculate your area. So again, our area formula is area equals 1/2 our base times our height. We plug those numbers in over here. Area equals 1/2 10 times 14. And notice I just wrote that height times base. It's all the same. It doesn't matter because you're multiplying straight through. Area equals 5 times 14. So the area of this shape is going to be 70. And our units again, meters squared, because it's units times units. Now, let's take a couple tries here to practice some different shapes. first step, we got to find our height and our base. Now notice here, there are two parts of this base, so we're going to have to add those numbers together. So our height is 5 for short. Our base is going to be 4 plus 10. That's why it's really helpful to trace all your lines. So our whole base is going to be 14. And then we just plug it into our formula. Area equals 1/2 times 5 times 14. So plug that all into your calculator and you'll get area equals 35. And whenever you see a number like 35, those little marks, those marks mean inches. So you're going to want to add inches squared. You can't just replicate the tick marks because we know that our units are now squared. All right, let's take a look at number 5 here. Again, our height and our base. Now this problem, we also have a number way over here that's looking at that slanted line. Because we're looking for area, we don't even need that number. All we need to know is that our height is 3, our base is 14, and to find area, we do 1/2 3 times 14. I like to kind of take a little step there. I know 1/2 of 14 is 7, so I'm going to say area equals 3 times 7. Cancel out our 14 and our 1/2. So area equals 21, and our units, millimeters squared. All right, now we're going to get a little bit trickier as we go through. Take a look at this problem. Again, recommendation, trace your base and trace your height. Wherever you see that right angle, those are the numbers you use. Any other numbers, you don't have to use them. So let's take a look. Our height is going to be 6.8. Our base is going to be 5.9. And to find area, we just set up our formula. Area equals 1/2 times 6.8 times 5.9. And again, these little quotation marks mean inches. So, I'm going to leave this one for you guys to see if you get the right answer. Did you get it? Let's see. So area is going to equal 1/2 times 6.8 is going to be 3.2 times 5.9. Hopefully you got there. And then that number is definitely a number for your calculator. So go ahead, type in 3.2 times 5.9, or you could have typed in the whole formula and you'll get area equals 18.88 inches squared. Perfect. All right, last of our warm-ups here. This again, remember, look for the right angle every time. There's my right angle, so I know that 5 is my height and 6 is going to be my base. Notice, I'm not using that 2 meters right here. Right here, is that part of your triangle? Is that inside our triangle? It's not. The only reason why it's out there is to show where the right angle happens. It's to prove that this is the right angle. So, we don't need to use that 2 to calculate anything. We know our height is 5 because that's where the tallest point of our triangle is. We know our base is 6 because we don't want that 2. It's not part of our triangle. And now we just solve. Area equals 1/2 6 times 5. So area equals calculate it yourself. Did you get 15 meters squared? And remember to put your units on. All right, now that we've practiced finding the areas of triangles, let's get a little crazy. So these shapes here are what we call composite shapes. They are made of several different shapes. Is there a formula that we can just use like we did with the area of the triangle? Find your base, find your height, plug it in? No. These are all just shapes put together. So the best way to do this is to break up your shape every time. I see this shape here, and what I see is 2 rectangles. Sorry, my calibration's a little off here, right? I see this 1 rectangle, and then I see this green rectangle over here. So what I'm going to do is find the area of both rectangles and then add them together. I like to really trace those rectangles so I know what I'm dealing with. So for the first shape, area of a rectangle is base times height. I know that this side here is 5 because it tells me that. My question is, how long is this bottom blue arc? Let's think about what we know. If I were to trace the whole line here, it would be 11, right? The red line is 11. If I look on my other rectangle, on my green line, I know the green part of that 11 is 8. So the question is, how much is left to give me the blue part? If we do 11 minus 8, we'll get 3. So I know this blue line has to be 3 because 3 plus 8 will give me my 11. So this rectangle is going to be 5 by 3, which means the area of this rectangle is 15. Perfect. Now we go to our second rectangle. Area equals base times height. I have an 8. I have a 3. So area equals 8 times 3. Area of that is 24. And then my last step is to take those two numbers and add them together. 15 plus 24 will give me 39. And when you see the single tick mark, that means feet squared. Perfect. This second shape gets a little wild, right? A lot of markings here, it's telling us a lot of things. Whenever you see the same markings, such as on these lines, we know they're all the same length. On the flat side here, they're all the same, so we know they're all the same length. The question is, what are those lengths? My first step is going to be to break up this shape. So I'm going to draw one line here, one line here. I now have 3 rectangles. I know these 3 green lines all have to add up to 27. And I know because of their markings, each of these green lines is equal. So if I do 27 divided by 3, I get 9. So I know this is 9, this is 9, this is 9. Because those three equal parts will make that 27 line. I know over here on the side, this blue line, I know those three lines equal 18. So I can do 18 divided by 3, and I get 6. So each of these is 6. Now, before we get too crazy, it's not that all these rectangles are 9 by 6. Our first rectangle here is 9 by 6, which gives us 54. This second rectangle is 9 by, here's 6 that they give us, but if we go inside our shape, there's another 6 and 6. Do we see how that line is twice as long? So that's going to be 9 by 12. And 9 times 12 is 108. For our last rectangle, again, I know it starts with a 9. 9 times 6, and then we said this whole length here was 12, because we have 6 and 6. This whole length inside the shape, I'll color it red, is 12, plus another 6. This line is the same as our blue line over here, so that last one is 9 times 18. So we have 9 times 18, which gives us pardon me, pulling out my calculator, 162. Our last step is to take these three numbers and add them. So we have 54 plus 108 plus 162 gives us 324 centimeters squared. Perfect. All right, our last tricky part. Sometimes when you have composite shapes, you have areas of those composite shapes that you don't want. So for these two shapes, all we want to find the area is the white part. We don't want the shaded area. So for this rectangle, I don't want anything other than the white box inside this shape. Well, that's easy. We can see that the white box here is just 4 times 8, which gives us 32 meters squared. Perfect. What if I wanted to find the shaded area? If I wanted to find the shaded area, all I need to do is find the area of the whole shape and subtract the area that I don't want. And we already found the area that we don't want if we're going in reverse. So area is going to be 12 times 24, which gives us 288. And we already found our 32, so all we have to do is subtract our 32, and that's going to give us the area of the shaded region. So we get 256 meters squared. Perfect. Now this last one's going to be a practice for you guys. See if you can figure it out, knowing what you know about rectangles and triangles. So our last step here is a little exit ticket. I'm not going to show you any of these. Go ahead back through the video, see if you can remember how to solve them. When you finish, we're going to collect it just so we can see how you did. And after that, Have a great day. Hope you enjoyed CraftTube. Take a little reflection now and think, did we meet our objectives today? Did you find the area of different types of triangles and develop multiple methods to find the area of composite shapes? If not, give yourself some extra practice. Other than that, we'll see you again for some more virtual geometry.